as we engulf ourselves in magic. The world of physical science leads you to another dimension of light. We are the batch 1 of Banatao, and good day, everyone.
Miska, Muska, Mickey Mouse. Good morning, everyone, and we are Batch 1 Disperse. And I am Anthony Estrella, your Mickey Mouse for today. Let's have a quick recap. So last session, we have the discussion about modern astronomy by the Batch 6. Let's proceed.
I want adventure in a great wide somewhere. Good day, everyone. My name is Joya Amare Ilaga, and I am your Princess Belle. And today, we're going to tackle about the photons. So what are photons? Photon is a piece of energy. It is a fundamental subatomic particle that carries the electromagnetic force, or in simpler terms, they are light particles. A photon has no mass and moves at the speed of light. As shown by James Clerk Maxwell, photons are just electric fields traveling through space. Photons have no charge, no resting mass, and travel at the speed of light. As you can see on the lower part of the slide, it is James Clerk Maxwell. He is best known for the formulation of the theory of electromagnetism and in making the connection between the light and electromagnetic waves. Disperse. A photon acts like a particle. Albert Einstein theorized that electromagnetic energy comes in packets, or quanta, which we now call photons. So light behaves as a wave and as a particle, depending on the circumstances and the effect being observed. This concept is known as the wave-particle duality. Also, a photon has momentum. Photons have momentum, even though they have no mass. The momentum of a photon is directly proportional to its frequency and inversely to its wavelength. If the wavelength of a photon is known, its momentum can be calculated using the formula that you can see on the lower part of the slide. P equals h lambda. The lambda indicates the wavelength of any wave, especially in physics, electronic engineering, and mathematics. And lastly, the energy of a photon is quantized. Photons are quantized particles. This means they exist only in discrete amounts of energy, rather than any amount of energy in between. That's all. Thank you.
Good day, everyone. I'm Sandara Delicano. For today, I am Princess Ariel, discussing to you why does a certain thing have a specific color, disperse. Objects appear different colors because they absorb some colors wavelengths and reflected or transmit other colors. The colors we see are the wavelengths that are reflected or transmitted. Example, stop sign is color red because that color is visible from greater distance as compared with other colors. Suspended microscopic particles in the air tend to scatter light. Scattering is inversely proportional to the fourth power of the wavelength. Red color has the highest wavelength and is therefore the color which scatters the least. It is property which makes it suitable for stationary warning and other applications like the stop signal. That's all. Thank you. Again, I am Princess Ariel from the Little Mermaid Disperse.
Okay, so good morning everyone. I'm Alexis Legaspi. So for today, I am Prince Navin discussing to you what will happen to a certain object when it absorbs too much photons. So first, let's define what is a photon. So a photon is a particle representing a quantum of light or other electromagnetic radiation and carries energy proportional to the radiation frequency but has zero rest mass. An object looks like a particular color because of the light they reflect and the light it absorbs. When a particular object absorbs too many photons, that substance will become very warm. This will radiate heat in electromagnetic radiation consisting of photons with a longer wavelength. So since it is proportional to the radiation frequency, the photon typically manifests itself as heating the matter up. This absorption of light makes an object dark or opaque to the wavelengths or colors of the incoming wave. So an example of too much absorption of photon is when we wear a black shirt during sunny days. Since black objects absorb too many photons, the shirt absorbs the sunlight and converts it into heat. That's why it makes us feel hot. That's all. Disperse.
So good morning everyone, I am Kanisha Lagdamen and I am Princess Merida, and today I will be discussing the formula of the distributed photons. Disperse. So wavelength of the light, E equals hf, where E is the energy per photon, f is the frequency of the photon, and h is Planck's constant. A single gamma ray photon, for example, might carry 100,000 times the energy of a single photon of visible light. So here is an example. When the sunlight hits the stop sign, all those photons that absorb the stop sign will get very warm and radiate the heat in the form of electromagnetic radiation, consisting of photons of longer wavelengths, wherein the infrared wavelengths and the wavelengths of those photons would be equal to 0.0029 divided by the temperature of the stop sign. So that is all. Thank you. Disperse.
Good morning everyone, my name is Yesha Gabriela Di Martin, and for today I am Princess Aurora, discussing you about a brief description of the two natures of light. Disperse. Light as particles. In physics, there are two theories about light which can be defined. The first one is the theory of light as particles. Light behaves mainly like a wave, but it can also consider to consist tiny packages of energy called photons. Photons can carry fixed amount of energy but have no mass. Einstein believed light is a particle or a photon, and which flow of the photon is a wave. The main point of Einstein's light quantum theory is that light energy is related to its oscillation frequency, the number of full oscillation in one time unit, say in seconds. According to Isaac Newton, in the particle model he proposed, the light bounces in a surface similar to a ball bounces. This light is called light corpuscles, a little particle that travels in a straight line with infinite velocity and possess impetus. Impetus means likely fast something to happen. Disperse. The second theory is light as wave. Light as wave is an electromagnetic wave comprised of energy derived from oscillation magnetic and electric field. Light is just one part of the electromagnetic spectrum, the part that our eyes can see. So, light behaves as wave. It undergoes reflection, refraction, and diffraction. In diffraction, the light around a surface and its interference upon the light produce a pattern that only we can see and observe in waves. René Descartes said that refraction of light is causing the formation of the rainbow. And meanwhile, Christian Huygens proposed a wave model and has a principles, the Huygens principle, which stated that all points of wave from the sound in transmitting medium of light in a vacuum or source of wavelets that expand in every direction at a rate depending on their velocity. He also stated that in reflection, the bouncing of the light wave in the surface simply cannot pass through, while in refraction, it was due to different speed in two mediums. And that's all for today. Thank you.
Good day, I am Jessica Birota, and for today I am Cinderella discussing to you what is reflection. How do we see things around us? We will probably say it is our eyes that help us to see the objects around us. But will our eyes be able to see these objects in the dark? No, we need light to see things. Without light, we cannot see the objects. But where is this light coming from? For example, the light is coming from a source like a fluorescent bulb. The fluorescent bulb emits its own light. The objects which emit their own light are called luminous objects. Incandescent light bulbs, the sun, and the stars are also examples of luminous objects. Tables and chairs are objects that do not emit their own light, and they are called non-luminous objects. Almost everything around us are non-luminous. Objects made up of wood, plastic, cotton, and metal are all non-luminous. Also, the moon and the earth are examples of non-luminous. If the moon is non-luminous, how come we can see this at night? The answer is the reflection of light. The reason we are able to see any non-luminous objects around us is because of the reflection of light. Reflection of light can simply be referred to as change in direction of light or bouncing of light from some surface. Just like the ball bounces back from the ground, light reflects off from a smooth surface. To explain further, the light from a source strikes the object and bounces off from its surface. And when this light reaches our eyes, we see the object. And this is how we see non-luminous objects. For example, we are looking at our body from a mirror. Our body is a non-luminous object. The human body cannot emit its own light. For example, the source of light is the fluorescent bulb. The light from the source is first incident on the human body. It gets reflected from it and this reflected light strikes the mirror. This light is further reflected from the surface of the mirror and reaches our eyes. And this is how we are able to see our image. That's all. Thank you. Disperse.
Good morning, everyone. I am Jardinero. I am Aladdin for today. And I am here to discuss what is refraction. Refraction is the bending of light. It also happens with sound, water, and other waves, as it passes from one transparent substance into another. Refraction is the bending of light. Light bends whenever it travels from one transparent material to another. One example of this is light traveling through a glass. The reason light bends when it passes between two materials is because it changes speed if the new material is more dense. For example, air to glass. The light slows down and bends towards the normal. Disperse.
Good day everyone, I am Allyza Mae Gumayagay and I will be Elsa for today. I will be discussing about René Descartes. So who is René Descartes? René Descartes was a French 17th century philosopher, mathematician, and scientist. He was also known as the father of analytical geometry. Analytical geometry in simple definition is combining algebra and geometry. He developed tools for deductive reasoning, a system for using letters as mathematical variables, and discovered how to plot points on a Cartesian plane. Descartes was also the one of the two scientists who explained the second nature of light, the wave model. He explained that rainbows are formed due to the refraction of light. Different colors of light are refracted at different degrees. He explained that red light is more refracted than violet light. That's why in the rainbow, red is the first color and it has the longest wavelength, while violet is the last and has the shortest wavelength. He was also known as the father of modern philosophy. Perhaps he is famous above all for saying the philosophical statement, I think, therefore I am. Originally, cogito ergo sum. Descartes intended to answer a question, how can one know that anything, including oneself, actually exists rather than being some sort of dream or phantasm? Descartes thought that everything might be a dream. He observed that our human senses are not reliable. However, he was sure that he could trust that he was actually thinking. He couldn't be thinking and wondering if he did not exist. Descartes was a fierce rationalist. He relies on reason and logic as the best guide for belief and action. Unlike many philosophers who back up their arguments with appeals to God, Descartes trusted and believed that nothing is more than the human power of logic. He wrote to the leaders of the French Revolution, he believed in grounding all of our ideas in individual experience and reason, rather than authority and tradition. That's all for René Descartes. Thank you. Disperse.
So good morning everyone, I'm Aisleen Joy D. Verano. For today, I'm Milan discussing the discovery of René Descartes. So now that we know who is René Descartes, we can say that he is really a skeptic. Well, skeptic is someone who questions if something can be known with certainty. And that's why he come up with numerous discoveries, and that includes his discovery in nature of light under the wave model. So, according to René Descartes, rainbows are the result of light refraction. He noticed that various views of light were refracting at different levels. In particular, he if the red light refracted more than violet light. Then, how does Rene Descartes come up with that discovery? Well, Rene Descartes discovered this after experimenting with water-filled glass and sunlight, which resulted in rainbows. Imagine, as light travels from air to water-filled glass, it causes the beam of light to bend, known as refraction. Each UV ray is bent different angle, allowing 7 colors to be seen. Those are red, orange, yellow, green, blue, indigo, and violet. So like water-filled glasses, raindrops behave by refracting light as it passes through them. And add to that, red light has the longest wavelength, around 700 nanometers. And bent release, on the other hand, violet light has the shortest wavelength, approximately 380 nanometers, which bend the most. And that would be all. Have a nice day.
Good day, everyone. My name is Jaifi Abuan. I will be Peter Panos for today, and I'm gonna answer the questions. The question was, who is Christian Huygens? Disperse. Christian Huygens. He was born on April 14, year 1629, and died on July 8, year 1695. He died at the age 66 years old. So, Christian Huygens is a Dutch mathematician, astronomer, and physicist who founded the wave theory of light, and has also discovered the true shape of the rings of Saturn and made the original contributions to the science of dynamics, the study of the actions of forces on bodies. For that will be for now.
Hello, my name is John Raven Adraboso. For today, I'm Guston discussing the discovery of Christian Huygens. He proposed a wave model that was different from Descartes. Based on the third theory, Huygens proposed that light travels in wave through a rare substance called luminiferous ether. The waves of light allegedly vibrates the ether as they travel from object to eye. With this as his foundation, Huygens calculated the laws of reflection and refraction, the longitude of the waves in which the medium moves in the same line as the waves. He also added reflection is the bouncing of waves and reflecting the surface or material it can pass through, while refraction is due to the speed of wave in two different media. That's all.
So, good day everyone. I am Eugene Marc Cobarrubias, and today I will be Prince Adam, and I will be explaining to you the frequency and energy of photons. So, frequency and energy of a photon is proportional or directly proportional, which means the higher the energy, the higher the frequency, and the lower the energy means the lower the frequency, and vice versa. So, frequency is the number of wavelengths a photon propagates per second. In other words, frequency is how many times a photon occurred in objects, in which is related to its energy, as the energy of a photon depends on its frequency. Meanwhile, energy of a photon is the amount of energy carried by a single photon, or the amount of energy it contains. And because of that, photons can be useful to all living things, especially to us humans. And certain colors that we see have different purposes. On the other hand, as you can see in the illustration below, energy of a photon and frequency is inversely proportional to its wavelength, which implies that the longer the wavelength, the lower the energy it contains and the lower its frequency. Which means with that, photons that are most frequently seen are those with shorter wavelengths, such as color violet, as it has the highest energy or the shortest wavelength. And energy and frequency of a photon can be expressed in an equation where E is proportional to F, which concludes that E is equal to hf, or where E is the energy of a photon, H is the Planck's constant, and F is frequency. And again, I am Prince Adam from Beauty and the Beast. Thank you.
How photons are used in photography. But first, I'll explain what is photon in photography. In other words, it discovers a laboratory camera that can photograph protons that are used as light particles. As they move through space, the camera, which has 500 sensors and a pulsed laser light source, captures images at a rate of 1 trillion frames per second. So, how does photons use in photography? A single photon leaving the surface of an object does not, of course, carry or store an image. It carries only its energy and momentum. Well, because a camera does not have a source, the net effect of which is that photons exiting the lens strike a photosensitive material that are used for retina, camera film, and screen. At any instant, an enormous number of the photons leaving the various points on the object will be traveling towards the lens. The net effect is that the point of the light-sensitive surface are absorbing photons, each carrying energy, which corresponds to frequency E equals hp, and the rate at which they are received corresponds to intensity. This the light-sensitive layer constitutes the image. That's all. Disperse.
Good day, everyone. I am Carl Lawrence Glenn El Panto. For today, I am Ian Life, discussing to you how do photons cause sunburns. The sun sends different kinds of energy to Earth. There is infrared radiation, sometimes known as heat. There is visible light, which our eyes can perceive. There is also ultraviolet light present. Despite the fact that we cannot see UV with our eyes, it can cause skin burns. Red photons are helpful for the photographers using light-sensitive photographic sheets because they do not overexpose and damage photos during the development process. UV photons, on the other hand, are more likely than visible light to induce sunburn because of their increased intensity. UV light causes everything from sunburn to skin cancer, as well as wrinkles and sagging as we get older. But what precisely does it do in our bodies to wreak such havoc? UV light is simply a more energetic variant of visible light. Because of its enhanced intensity, UV in sunlight is detrimental to our cells and tissues. UV light must be absorbed in order to cause injuries. This happens at the molecular level. It happens one electron at a time. There are two types of UV radiation in the sun, UVA and UVB, which has more energy. The difficulty occurs when they are absorbed by our more critical molecules, such as DNA, RNA, or proteins. Disperse.
Hi, I am Hazel Ann Alvarez, aka Anastasia. So let's learn more about the contribution of Mr. Isaac Newton to the concept of light. As we all know, Isaac Newton is famous for his discoveries in optics or white light composition. His discovery of the composition of white light integrated the phenomena of colors into the science of light and laid the foundation for modern physical optics. Second, the core of Newton's contribution had to do with colors. Based from an ancient theory extending back at least to Aristotle held that a certain class of color phenomena such as the rainbow arises from the modification of light. So now let's talk about the nature of light. The explanation for the appearance of the rainbow colors was about the impurities added by the prism to the pure white light. Isaac Newton thought that the colors were already present in the sunlight, so he made his experiment. First, he made a rainbow by shining white light through a prism, and then he introduced a slit into that rainbow beam that is allowed to isolate a particular color of light and shine it to a second prism. Next step, he looked for the deflection of the colored light onto his wall. Simply, the color into the prism is equal to the color that lights out to the wall. The colors themselves are the basic building blocks of light, and white light is made up of all individual colors. Light consists of corpuscles. In conclusion, Newton thought that light was composed of extremely subtle corpuscles, an idea reflected in the vision of light onto photons today. His use of multiple prisms is described in his Optics, published in 17th century, were arguably some of the initial experiments that led eventually to the development of tunable lasers. When the corpuscles or small particles hit the reflecting surface, they are reflected from it in a such way that the angle of incidence is equal to the angle of reflection. That would be all. Thank you. Disperse.
Good morning, I am Alec Lehanco and I will be Christoph for today. And I'm going to answer the question, where does the photon belong in the electromagnetic spectrum? Photons belong to the subsection of the radio wave segment of the electromagnetic spectrum. All parts of the electromagnetic spectrum is composed of photons, but photons is mostly found in visible light, disperse.
So this topic is important for us to learn that photons is basically important to our daily lives since photons is what makes us see colors. That will be all. Thank you and goodbye.